Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have a function of 3 variables. Function expression is right here. We have to first find if there are any critical points to this function, and then looking at the form of the function, we have to determine if at that critical point, if it has a relative max or a relative mean. Now, to compute critical points for a function, we have to use the first partial derivatives. So let's start by computing fx, and that is partial derivative with respect to x of the function, which is x minus 1 square plus y plus 3 square plus z square. Now, notice that since this is the derivative with respect to x, it's a partial derivative, therefore, any other variable, in this case y and z, they are both considered to be constant. So look at these 3 terms. Look at the second term. There is y plus 3 square. There is no x. So this entire term will be considered a constant. Same for the last term. It is a z square. There is no x. So this is also a constant. So the derivative will be just the derivative of the first term, which is 2 times x minus 1, and then plus 0 plus 0. Okay. Now, let's compute fy, and that is the partial derivative with respect to y of the function. In this case also, since it is a derivative with respect to y, therefore, x and z, those 2 variables are considered constant. So the first term is a constant because there is no y, and look at the last term is z square, also there is no y, so this is also constant. So the derivative will be just the derivative of the second term, which is 2 times y plus 3. Okay. And then finally, let's compute fz, which is the partial derivative with respect to z of the function. And as before, since this is with respect to z, therefore, x and y are considered constant. So the first term is a constant and the second term is a constant. So the derivative will be just the derivative of third term, and it is 2z. Okay. Now, how do we compute critical point? We have to set each of these partial derivatives equal to 0 and see what point we can find. All right. So fx equals 0 gives us 2x minus 1, that's the expression for fx, and that is 0, which means x minus 1 is 0. You divide both sides by 2, which means x is equal to 1. Okay, let's go back to fy now. To do the same thing here, fy is 0, which means 2 times y plus 3 is 0. So y plus 3 is 0, and therefore y is negative 3. Finally, we want fz to be 0. So 2z is 0, and divide both sides by 2, you get z is 0 as well. So we have a point, and the point is 1, negative 3, and 0, and that is the critical number or critical point of this function. Okay, so we have our critical point. Now we have to determine whether it will be a relative max or relative mean looking at the form of the function itself. So let's go back to this function. Notice that the expression of the function is sum of these 3 terms. And each of these terms is a square. a complete square. So it's a sum of squares. So whatever x, y, z value you plug in, what will happen to the output? What can we say from this particular expression? It's a sum of squares, and squares means the output will always be a positive quantity or 0, right? But it will never be negative because these are all squares. So we know that the range, and that is the range of the function. So the range of f is always positive, right? Now, where will the range be equal to 0? Where will the output be exactly 0? Look at each term again. It will be 0 if this quantity is 0. So x has to be 1, right? X has to be equal to 1. Y has to be equal to -3. Then this will be 0. And z has to be 0. So what is the point where this function will be 0? Exactly at this critical point, 1, -3, 0. So function is 0 at this point, and everywhere else the function will be positive, greater than 0. So what do you think this point is? It is the minimum point, right? So this point will be a relative minima, because everywhere else the output will be greater than 0. It's only 0 at this point. Thank you.